Okay, so this is the problem I'm doing to demonstrate both of these standards, 8 and 9. The question is, how much work would the electric field do on a 4 nanocoulomb charge if moved from A to B? And then what are the electric field vectors at A and B? So I got this diagram off the internet, just so I can describe it myself and figure it out. So first of all, we know what Q is. So Q is equal to, actually, let me do this. So Q is equal to 4 nanocoulombs, which is then equal to 4 times 10 to, it would be the negative 9th coulombs here. And then, so in order to figure out this, we have, we need to know the potentials at A and B. But this diagram has interesting units. So what I'm just going to do is ignore the letters, change them a little bit just to make it work. So this will be negative 0.2, where A is starting. Actually, 0.2, negative. Then where this one is, it's going to be this 1 is what the line is on there. So let's just erase all that. Then we can actually write it down here to make it a little more clear. So 0.1. Okay. And this is all in volts. So we know now that the A potential equals negative 0.2 volts. And the B potential is 0.1 volts. Okay. And so now the equation for work is work equals Q, and then we do V, but in this case it is going to be delta V. So to find delta V, that is simply going to be the difference in potential. So it is going to be going from the, where is it? Right here, the 0.2 and the 0.1. So the new one would be 0.1 volts, and then we can do minus the negative 0.2 volts. So that is going to give us a delta V of 0.3 volts. Okay, now let's plug that into work. So we have W equals 0.3 volts for delta V, and then multiply that by Q. And we said Q is 4 times 10 to the negative 9th coulombs here. So then that gives us work equals, plug that in, 0.3 times 4. One more time. Okay, so that's going to give us work of 1.2 times 10 to the 9th.